Hello everyone, welcome back to our course. In this chapter, we will cover the foundation of YUM resource scheduling implementation principle. Again, firstly, let's have a look at the overview of YUM. So YUM is actually an abbreviation of yet another resource negotiator. So from its full name, you can find that it is used to negotiate cluster resources. But here, we say that it is another resource negotiator. So you may be curious, what is the first one? Actually, YUM was introduced in Hadoop version 2.0. Slightly later, we will draw a comparison between Hadoop 1.0 and Hadoop 2.0. But in order to answer your question, the first resource negotiator is just MapReduce or MRV1. So it means that MapReduce needs to take care of the resource allocation on its own, and meanwhile, it needs to do the complicated calculation. So there were always some problems. And then YUM was designed to provide unified resource management and scheduling for all the up-layer applications. As we can see from the graph below, including MapReduce, Storm, Spark, Flink, and so on. So MapReduce now is free from complex resource coordination and only focus on batch data processing. And what resources are managed by YUM? In most cases, CPU and memory, or RAM, to be more specific. But in the latest version of Hadoop, YUM is also capable to manage resources such as GPUs, software licenses, and so on. But you need to remember that YUM only cares about the computing resources. So the hard disks and HDFS is not managed by YUM. Then, how about the architecture of YUM? Again, YUM has its own cluster of servers, and it also follows a typical master and slave architecture, as shown here. Now, the master node in YUM is called Resource Manager. It is the boss, and it is in charge of the resource management for the whole cluster. And the node manager is like a department manager. They are running on all nodes in the cluster to launch and monitor containers, which also report node status to resource manager periodically. What's the meaning of a container? You can regard it as the abstraction of resources provided by YUM. So a container is a package of computing resources which calculates all task instances. The container executes an application-specific process with the constraint set of resources, including memory and CPU, as we mentioned before. And it reports the status of MapReduce tasks to application master. So, what is an application master? Application master is just a very special container, which is like a team leader, and is responsible for negotiating resources from the resource manager and working with the node manager to execute and monitor the component tasks. Please remember, an application master is a special container, but it has more responsibilities. When a job starts, it is the application master that calculates how much resource is required and then apply for it from resource manager. Secondly, it is also the application master who notifies the resource manager to recall the resources back after the task being completed. But how does Yum schedule MapReduce tasks? This may be a little bit too complicated, but don't worry if you cannot understand it all, because in real work, you do not need to remember it. So simply regard it as a story, and I will follow the slide to do the instruction. So from the graph, you may notice that, again, the application needs to be submitted by the client, and one application master is responsible for one application submitted by one client, and all the tasks are submitted to the boss directly. Then the boss distributes the tasks to different nodes in the cluster with different node managers. So after the node manager receives the tasks, it starts a container as the application master. And application master applies for resources from resource manager as this gray dash line indicates. And the tasks are now running in the containers, while the containers need to report the working status back to application master. And when at working, the node manager needs to report node status back to resource manager. And that's exactly the process of task scheduling of MapReduce task on Yum in detail. But in short, Yum just does two things here. So job checking and process monitoring. And finally, we can conclude Yum by comparison between Hadoop 1.0 and Hadoop 2.0, as we mentioned before. In Hadoop 1.0, the cluster management is limited by job checker performance and is difficult to scale. But Hadoop 2.0 introduces the new resource management framework Yum to solve this problem. In Hadoop 1.0, only job checker and task checker processes exist. In Hadoop 2.0, Yum separates job checker resource management and task scheduling functions, which are implemented by resource manager, application master, and node manager. In Hadoop 2.0, Resource Manager manages and schedules resources of the entire cluster, and Application Master is responsible for application-related transactions. The Node Manager is the resource and task manager of each node. So in Hadoop 1.0, cluster resource utilization is low, and the number of MapReduce task slots is fixed and the resource cannot be reused. In Hadoop 2.0, Yum is used to manage cluster resources and containerize computing resources. There is no fixed MapReduce task slot. Resources can be dynamically allocated and reused. Finally, Hadoop 1.0 supports only MapReduce, a batch processing computing framework. But Hadoop 2.0 uses the two-layer scheduling idea that resource management and task scheduling are separated, so that multiple computing frameworks can share resources of a cluster, including MapReduce, Spark, and Storm. Each application corresponds to its own application master. So from the comprehensive comparison, perhaps you can understand why people prefer Yum clusters to run all the big data computation tasks instead of in standalone modes. Alright, that's all for this chapter about Yum. In this chapter, we mainly introduce what is Yum, its architecture and scheduling processes, and a comparison between Hadoop 1.0 and Hadoop 2.0, particularly on the resource allocation aspect. Hope you guys enjoy all the contents in this chapter and see you in the next chapter.